Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from May June 2022, paper 2, variant 2. Today's class, we will start from question number 2. In the last lesson, we have discussed question 1 on measurements. So for the solution of that question, you can go to mechanics part 01. Today's class, we will start from question number 2 and we will discuss questions on kinematics, forces, energy and power in today's class. Let's study together. Let's improve together. Before we start working on question number 2, I just want to highlight some points about writing measurements with absolute uncertainties. For this question, we have already discussed that the value of E is equal to this, and delta E means the absolute uncertainty. In E, we have also calculated that was equal to 0.47 times 10 to 9. Now, in this case, you can see we have value of E that is equal to 8.245 times 10 to 9, and delta E is also given to us. Now we need to use appropriate number of significant figures and we need to write down our answer. So in order to write answer for this question, we need to consider first of all number of SF in absolute uncertainty. Absolute uncertainty, you have to write down up to 1 SF. I mean, you need to round this one up to 1 SF, one significant figure. So if we round this one up to 1 SF, simply we can write down this will be equal to, because 7 is greater than 5, so we can write down 0.5 times 10 to 9. Now absolute uncertainty has 1 SF, so we can write down absolute uncertainty here. So this is 0.5. Now we need to consider how many decimal places absolute uncertainty has. Absolute uncertainty has only 1 dp. So this measurement also must have 1 dp. So simply we can write down this one up to 1 dp. This will be 8.2 times 10 to 9. So we can write on here 8.2. Now step 1, the first point you need to understand is absolute uncertainty has to be rounded to 1 SF. And the second thing you need to understand, absolute uncertainty and measurement, they should have same dp. So this is the point you need to understand. For question number 2, it is given to us a sphere is attached by a metal wire to the horizontal surface at the bottom of a river, as shown in figure 2.1. The sphere is fully submerged and in equilibrium, with the wire at an angle of 68 degrees to the horizontal surface. The weight of the sphere is 32 newtons. Upthrust acting on the sphere is 280 newtons. Density of the water is given. For this question, we can also assume that the force on the sphere due to the water flow is in horizontal direction only. Let's move on to second part. If you look at the second slide, you can see question is asking us for part A, we need to consider the components of the force in the vertical direction and we need to determine the tension in the wire. So this is the hint. Question is telling us we need to consider vertical direction. So it means you have to resolve forces in vertical direction. So this is kind of hint given to you. If you see any hint given in the question, follow that and that will make your life easier. Now let's try to understand first of all forces acting on the sphere. One thing we need to understand, if you look at the sphere has a mass, so the weight of this sphere has to be acting downwards. So simply we can say W is acting downwards and the magnitude of W is given, that is equal to 32 newtons. Upthrust is also given. Upthrust is acting on the sphere, so we can draw upthrust is acting up and the value of upthrust is given, that is equal to 280 newtons. Now we need to find out direction of tension. Now if you look at this ball, imagine that we cut this string. If we cut this string, horizontal force is also acting on the sphere and that is acting to the right. So this sphere will go this way. Now, if you look at this sphere is at rest. It simply means that tension is acting downward. So simply we can draw direction of tension. So this is a tricky part. Maybe some student, they will draw direction of tension in wrong direction. So now you can see these are the forces acting on this sphere. There is also force acting on this sphere that is due to water flow. So we can simply say this force is F. But magnitude of force due to water flow is not given, so we no need to worry about that. We can answer this question by resolving forces along vertical only. Now we need to understand tension has two components, so we can resolve this one into two components. So if I draw a triangle here, so you can look at this triangle. If you look at this triangle, these are horizontal and vertical components of tension. So you can see one component of tension is acting to the left, and this one has to be equal to F. And one component is acting down. If this angle is 68, this one will be 90 minus 68, and this angle, this will be equal to 68 degrees. Now this component of tension, this will be T sine of 68 degrees, and this one will be T cosine of 68 degrees. Now if we take this sphere, I will redraw this one here, and I will only draw forces acting on this sphere in vertical direction. So I will write on here vertical direction only, along vertical direction. If you look at this sphere and we draw the forces acting on this one in vertical direction only, you will see there are only three forces acting on this sphere. One force is acting up, and this force is upthrust, and magnitude of this one is equal to 280 newtons. Weight of this sphere is acting down, that is W, and magnitude of this one is 32 newtons. There is component of tension that is also acting down, and that component of tension is equal to T sine of 60. So simply we can write down T sine of 68 degrees. Sphere is not moving along vertical, not moving up and down. It simply means that T sine of 68 degrees plus W, this one is equal to upthrust, or simply you can say downward forces in this case are equal to upward forces. T sine of 68, so again we can write down T sine of 68 degrees, W is equal to 32, and U is equal to 280. We need to find out value of T. So simply we can write down this is 280 minus 32 divided by sine of 68 degrees. If we solve this one, value of T will be equal to 270 newtons. And this is value of T, and this is our final answer. This is what question was asking us to calculate. This question has 2 marks. You will get first mark, that is C mark, if you have written this, and the second mark is answer mark. If you have got the right answer, you will get the second mark. So this is how you can approach this problem. For part B, we need to calculate volume of sphere, and we also need to calculate density of sphere. But for this question, it is given to us upthrust acting on the sphere is equal to 280 newtons. Weight of the sphere is given, that is equal to 32 newtons. And density of the liquid is also given, that is equal to 1.0 times 10 to 3 kgs. We need to calculate volume. Upthrust is given to us, so simply we can say upthrust, this will be equal to density of fluid times volume of fluid displaced times G. We need to calculate volume of sphere, but in this case sphere is fully submerged, so we can write down here, in this case sphere is fully submerged in liquid. Is fully submerged, it simply means that volume of fluid displaced Ft, this is equal to volume of sphere. So this is very important point you need to be clear about this one. So in this case, this is volume of fluid displaced, but this is also equal to volume of sphere, and we need to calculate this volume. So simply we can say in this case, volume of sphere, this is equal to upthrust divided by density of fluid times G. Now simply we need to plug in values. If we plug in values, we can find out value of volume. Upthrust is given, that is equal to 280. Density is 1000 kgs per kilogram, and G you have to use 9.81. If we solve this one, we will get volume is equal to 0.029 cubic meters. So this is our final answer up to 2 SF. So this is answer for part B1. And this question has only 1 mark. If your answer is right, you will get 1 mark. Now we need to calculate density, but we understand mass is equal to density times volume. We need to find out density. So it means density will be equal to mass of sphere divided by volume of sphere. So this is volume of sphere. For this question, we have weight of sphere. Weight of the sphere is given, that is equal to 32 newtons. So mass is equal to 32 divided by 9.81. So this is the mass. Weight divided by G. And we need to divide by volume of sphere. If we simply plug in these numbers into calculator, our final answer will be equal to 110 kgs per cubic meter. And this is the final answer. So we can write down here 110 up to 2 SF. This question has 2 marks. You will get first mark if you have written this step. Means you have entered value of mass and volume. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part C, it is given to us the center of the sphere is initially at a height of 6.2 meters above the horizontal surface. The speed of the water then increases, causing the sphere to move to a different position. This movement of the sphere causes its gravitational potential energy to decrease by 77 joules. So you need to understand decrease by. So it decreases by 77 joules. Not decreases to, decreases by. So very important point. We need to calculate final height of the center of the sphere above the horizontal surface. So first of all, sphere is here, and in this case, height of the sphere is given. So simply we can draw from the center of this sphere. So this is the initial height. We can label this height as h1. So this is the initial height of the sphere. And then its gravitational potential energy decreases. It simply means that height of this sphere decreases. So we can imagine sphere is at this position now. And for this one, we can also draw the line, so you can imagine sphere is here. Let me redraw this one so you can see better picture of this. So we can draw the line from the center to this point. So the sphere is at this point now, and the height of this one we can also draw the line. So this is new height, and we can say this height is h2. We can also label the difference in heights. So this is the difference in height. So this is the decrease in height. We can label this one by delta h. First of all, we need to calculate delta H. So we can write down the change in GPE. This will be equal to mg delta H, the change in height. We need to calculate change in height. So this will be equal to change in GPE divided by mg. Potential energy decreases. So we will be using negative sign here. It decreases by 77 joules. So we are using negative sign here. And we have to divide this one by weight of the sphere. That is equal to 32. Now if we solve this one, our answer will be negative 2.4 meters. Means the decrease in height is equal to 2.4 meters. We need to calculate final height. Means we need to calculate h2. Now we have calculated h2 minus h1, and this one is equal to negative 2.4. We need to calculate h2. So h2 simply we can say that will be equal to negative 2.4 plus h1. H1 was given to us, and that is equal to 6.2 meters. This one is equal to 6.2 meters. So we can plug in value of h1, that is 6.2. So the final answer will be 3.8 meters. So the second height, or simply you can say the final height of sphere is 3.8 meters from horizontal, and this is our final answer. This question has 3 marks. The first mark you will get if you have written this formula. So if you have written the formula, you will get 1 C mark, and the second mark you will get if you have got right value of decrease in height. And the final mark is answer mark. This is answer mark. Part D, it is given to us the extension of the wire increases when the sphere changes position as described in C. The wire obey Hooke's law. Very important point. Wire obey Hooke's law. Extension of the wire increases. State a symbol equation that gives the relationship between the tension in the wire and its extension. Identify any symbols that you choose. Now in this case we need to understand this is the wire. So when this wire extends, it simply means that tension in this wire increases and this wire obey Hooke's law. As this wire obey Hooke's law, it simply means that tension is directly proportional to X. Now simply we can say T is equal to Kx. So simply you have to write down T is equal to Kx, and the symbol we have used is K. So you can say K is a constant. So that's all what you need to write down. This wire obey Hooke's law. So simply you can imagine that this one is the wire. As tension in this wire increase, extension of this wire will increase. But this wire obey Hooke's law. So tension and extension, they are proportional to each other. So simply you have to write down T is equal to Kx. And this question has only 1 mark. If you have written T is equal to Kx and you have written K is constant, you will get 1 mark. Very simple question, very straightforward one. For the second part, it is given to us before the sphere changed position, the initial elastic tension energy of the wire was 0.65. The change in position of the sphere causes extension of the wire to double. We need to find out the final elastic tension energy of the wire. So first of all, let's write down what is given to us. For this question, it is given to us initial elastic potential energy, EPE. We will simply write down EI. This one is equal to 0.65. Initial extension, we can say XI, that is equal to X. So imagine that that is simply equal to X. It is also given to us that E final. This is what we need to calculate. But it is given to us X final, means the final extension. This is equal to 2 times of initial. So we can say this one is equal to 2x. Now we need to understand elastic potential energy. How we can calculate EPE, elastic potential energy. EPE is equal to 1/2 K times X square. If we rearrange this one, EPE, we can say this is equal to E, and if we divide this one by X square, we also need to divide this one by X square. So simply we will get here that will be equal to K by 2, and K is spring constant, and this is same for the same wire. So we are talking about the same wire. So we can say this is simply equal to constant, is equal to K by 2. So simply we can say this is constant. Now we need to understand we have EI, the ratio between EI, it simply means that over XI square, this one has to be equal to E final over X final square. We need to calculate EF. So we can rearrange. So final elastic tension energy, this one will be equal to initial elastic potential energy times X final square divided by X initial square. Now simply we need to plug in values. EI is given, that is equal to 0.65. X final, this is equal to 2x, and here we have only X squared. Now we need to simplify. So in this case we have 0.65 times 4x square divided by X square. So X square we can cancel with X square. We left with 0.65 times 4, and this is equal to 2.6 joules, and this is our final answer. This is one way you can approach this problem, but you can also approach in different ways. So this is the simplest way to approach this problem. One way to find the answer for this question is simply you can understand if x is double, it means this energy is 4 times. So the final energy has to be 4 times of initial energy. So E final has to be equal to 4 times of E initial, because extension is double, but the square of that is 4. So the E final has to be equal to 4 times of E initial. Why this is 4 times? Because energy is proportional to x squared. So if this is double, this has to be 4 times. So that is the main concept. This question has 2 marks. The first mark you will get if you have used this formula. So you will get first mark if you have used this one. So this mark will be C1, and you will get final mark, that is answer mark, if you have got the right answer. So this is how marks will be awarded for this question. For third question, it is given to us: a man standing on a wall throws a small ball vertically upwards with a velocity of 5.6 meters per second. The ball leaves his hand when it is at a height of 3.1 meters above the ground, as shown in figure 3.1. Assume that A resistance is negligible. For part A, we need to find out the ball reaches the maximum height above the ground is 4.7 meters. We need to find out maximum height. In order to find maximum height, we need to consider initial height of the ball as well. So the maximum height will be equal to initial height plus displacement. So we can say plus vertical displacement, or simply we can say displacement. This is how we can calculate maximum height. Initial height is given to us, that is equal to 3.1 meters. Now simply we need to find out its displacement. Let's try to understand motion of this ball. This ball has initial velocity, and direction of initial velocity is vertically upwards. This ball will go vertically up, but force of gravity is acting down, so this ball will slow down. Finally, this ball will reach its maximum height, and at maximum height v will be equal to 0, means the final velocity of the ball at maximum height will be equal to 0. We need to find value of vertical displacement. In order to find vertical displacement, we need to use kinematic equations, because ball is moving vertically upwards and the force acting on this ball is only gravity. So acceleration of the ball is constant, so simply we can use kinematic equations. Let's try to use equations and try to find out displacement of this ball. Let's say the displacement of the ball is s, and we need to find out value of s. Initial velocity of the ball is given, that is equal to 5.6 meters per second, and direction of initial velocity is vertically upwards. We have value of v, the final velocity, that is equal to 0 at maximum height, and also we have value of a, that is equal to 9.81, and this is acceleration due to gravity. As gravity is acting down, so acceleration is also downwards, means direction of acceleration is downwards. We need to find s, so simply we can use kinematic equations. Now in this case we can use 2as, that is equal to v squared minus u squared. We need to find s, so simply we can rearrange this. We can say s is equal to v squared minus u squared divided by 2a. Now we need to take direction. One direction we have to take positive, so in this case we will take up is positive, because direction of initial velocity is positive and displacement is also up. So if you take up positive, your answer will be positive. If you will take down positive, your answer will be negative. So in this case we will take up is positive. So if we take up is positive, it means that initial velocity is positive but acceleration is negative, because it is in opposite direction. Now simply we need to plug in values. So this is 0 square, and u is equal to 5.6 divided by 2 times negative 9.81. Now if we solve this one, we can find out value of s, and value of s in this case will be equal to 1.6 meters, and this is vertical displacement, and this is positive. It means displacement is vertically upwards. Now simply we have to write down this value here, 1.6. So the final answer in this case will be 4.7 meters, and this is the final answer. This question has 2 marks. The first mark you will get if you have used this formula. If you have used this formula, you will get 1 mark, and that is C mark. If you have used this formula, you will get 1 mark. And the second mark is the answer mark. If you have got this answer right, you will get the second mark. So this is how marks will be awarded. For part B, we need to calculate the time taken for the ball to fall from its maximum height to the ground. So very important point, you need to understand what you need to calculate. For this question, simply we need to calculate time taken for the ball to fall from this maximum height to the ground. And maximum height we have already calculated in part A. Maximum height in part A we have calculated, and value of maximum height was equal to 4.7. So this is value of at max. At this point, at maximum height, we have also discussed that the speed at maximum height is equal to 0. So now this is our initial velocity. So the initial velocity in this case is equal to 0. We need to find out the time taken for the ball to reach from this point to this point. And in this case, we need to understand only force acting on the ball is gravity. So it means acceleration of this ball is equal to g. So simply you can write down this is 9.81 meters per second, and direction of acceleration is down. As the ball is falling, is moving downwards, so in this case we will take downward as positive. Mean downward direction we will take positive. U is equal to 0. We need to find out time taken. In order to calculate time taken, simply we can use S is equal to UT plus 1/2 AT squared. As U is equal to 0, it simply means that this is equal to 0. It simply means that S is equal to 1/2 AT squared. S is equal to H max, means this is the vertical displacement. Now we need to find out value of T. So we can rearrange this one. We can write down T square. This will be equal to 2S divided by A. Or we can say that T will be equal to 2S divided by A root of this. Value of S is equal to 4.7 meters and A is equal to 9.81. And this is positive because we are taking downward direction as positive. So this value is positive. Now if we solve this one, our final answer will be 0.98 seconds. So the answer for this question is 0.98 seconds. So this is our final answer. This question has 2 marks. The 1 mark you will get if you have used this formula, or simply we can say if you have plug in values in this formula, you will get 1 mark, and that is C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. So this is how you can calculate. For part C, it is given to us the ball leaves the man's hand at time t is equal to 0 and hits the ground at time t is equal to capital T. So at this point, value of t is given, that is equal to 0. And when the ball hits the ground, value of t is equal to capital T. For this question on figure 3.2, we need to sketch a graph to show the variation of the velocity of the ball with time t from t is equal to 0 to t is equal to capital T. Numerical values of v and t are not required. Assume that v is positive in upward direction. So this is very important. Now we need to understand when this ball will go up. So I will redraw here. So you need to understand what is happening. So ball will go up like this and then ball will come down. So this is how ball will move. Now if you look at motion of this ball, when the ball is moving up, acceleration due to gravity means that g is pointing downwards. So the ball will slow down in this region. So we can say from point, let's say this is point A and this one is point B, and this is point C, and let's say this is point D. If you look at A and B, between A and B, ball will slow down, so its speed will decrease. So we can say between A and B, ball will slow down, and at B, speed of the ball will be equal to 0. And then between B and C, we can write down between B and C, ball will speed up. So we can say ball will speed up. Its velocity will increase. Now we need to understand when the ball is moving up. We have taken, in the question it is given to us that upward direction is positive. So it means when the ball is moving up, V is positive. So we will take V here is positive, V here is 0, and V here when the ball is moving down, so V is negative. So V is negative. At point C, we can write down at point C, value of the velocity means the magnitude of the velocity VC, this will be equal to VA. So at this point, velocity is vertically upwards, but when the ball is here, velocity will be downward, but the magnitude of velocity will be the same because it is the same height. But when the ball will go down, the speed of the ball will keep on increasing due to force of gravity. So we can say between C and D. So I will be writing here between C and D at this point. Between C and D, speed of the ball is increasing, but this is negative. When the ball will reach at D, we can write down speed of the ball at D. This will be greater than speed of the ball at A. But velocity of the ball at D is negative and at A is positive. So we can say VD is negative, but it is greater in magnitude than VA. And VA, we can say this one is positive. Now simply we need to sketch this one. And also we need to understand acceleration of the ball is always negative and downward. So we can say the gradient of the graph has to be constant. Gradient has to be constant. It must have only one value, and gradient has to be negative because gradient is equal to acceleration, and acceleration is vertically downwards, and we have taken up is positive. So the gradient of the line has to be negative. And velocity VA, at this point we can write down VA. Let's say we have velocity VA at this point, and here let's say we have VD. So VD has to be greater in magnitude than VA. So that's the reason you can see VD is greater than VA. Now simply we need to connect these 2 points. Means we need to draw a line. So let me draw a line. You need to simply draw the line. So we have initial velocity here and this is the final. It just need to be a sketch. So this is how you can draw the line. That's all what you need to do for this question. This question has 3 marks. 1 mark you will get, first mark you will get if you have shown that VA is less than VD in magnitude. And the second mark you will get if the slope of this one is constant. Gradient is constant and negative. Gradient is constant and negative. You will get second mark. Gradient is constant and negative. Means gradient has only one value. You also need to show in your sketch that VA means the initial velocity is positive and the final velocity VD, this is negative. So if you follow these 3 points, you will get 3 marks. So this is how marks will be awarded. I hope this part is clear to you. For part D, we need to state what is represented by the gradient of the graph in C. So simply you need to write down what is gradient of VT graph, and gradient of VT graph is equal to acceleration. So simply you can say gradient is equal to acceleration of the ball. If you simply write down acceleration, that is quite enough. But in this case, acceleration of the ball is equal to acceleration due to gravity, because in this case there is no air resistance. So simply if you write down acceleration, you will get 1 mark, and this is B mark. For part E, it is given to us a person throw a second ball with the same velocity and from the same height as the first ball. The mass of the second ball is greater than the mass of the first ball. Assume that A resistance is still negligible. For the first and the second ball, we need to compare magnitude of accelerations, and also we need to compare the speeds when they hit the ground. So first of all, let's try to understand, if we change the mass, what is effect on acceleration? Let's say we have one ball that has mass small m, so we can imagine this is first ball. We can take an other ball, let's say the mass of the other ball is capital M. If we look at force of gravity, it means the weight of this ball. Simply we can say weight of this ball will be equal to mg, and only force acting on this ball is mg, so we can say the net force on this ball is equal to mg, and net force is equal to ma, so this is equal to mg, so mm cancel, so a is equal to g. Now if you look at second ball, now we need to understand, if there is no air resistance, there is only one force that is acting on this ball, and that is force due to gravity, and that is equal to weight, so we can say weight, and weight of this second ball will be equal to capital mg, so the net force on the second ball is equal to capital mg, and the net force also is equal to ma, so we can say this is equal to mg, so mm cancel, so it simply means that acceleration due to gravity is independent of mass. So you need to be very clear about this point. So from here simply we can say here A is also equal to g. So acceleration due to gravity is independent of mass if there is no air resistance. So for the first case, simply we can say acceleration will be the same, or simply you can say they have equal magnitude of acceleration. Next we need to consider the speeds. Now let's take first ball. This ball here, we will take the small ball and then we will take the heavier ball. So this ball initial velocity is u, and u is equal to 5.6 meters per second. So we can simply say u. This ball will go up and this ball will come down and it will hit the ground at this point. If you look at final speed of this ball, means the v, we can say 2as. This is equal to v square minus u square. So the v square in this case will be equal to 2as plus u square. So this is the equation for the first ball. Now let's take the second ball. So this is the heavier ball. We throw this one up, this will go up, and finally this will hit the ground, so it will hit ground at this point. For this ball, we need to understand A is the same, height is the same, initial speed of this ball. We throw this one up with the same initial velocity. So the U for this one is also equal to 5.6, or it can be any number. So I'm just writing what was given to us. So its initial speed is equal to 5.6 meters per second. So we can also calculate its final speed. So final speed of this one also will be equal to 2as plus u square. Now we need to understand, for both balls we can write down, for these two balls we can say for both balls A is the same, A is equal to g, and the initial velocity is also the same, so we can say u is equal to 5.6 meters per second, and the height is also the same, so we can say the height means we throw them from the same height, so h is equal to s, so this is also the same. So it means they have the same speed. So if A is the same, S is the same, U is the same, it means V is also same. So it means that both balls, when they hit the ground, they will hit the ground with the same speed. So they will hit the ground with the same speed as well. So or simply you can say, in this case, the final speed is also independent of their masses. So mass is not playing any role in this case. This question has only 1 mark, and that is B mark. If you have written this point, you will get 1 mark, and this also has B mark. If you have written same or equal, you will get this mark.